So we start with the very familiar numbers we call the natural numbers. We start from down here. We start from down here because we're walking up to the whole real numbers. So we start from natural numbers. Natural numbers. Okay, natural numbers. What are natural numbers? So we have the natural numbers are those numbers that we use naturally. For example, somebody tells you to count the number of people in your class. You are in a class and somebody says, can you please count the number of people in this class? What do? You start from 1, 2, 3, 4, 5, 6. Okay? You don't start from 0. You don't start from -1. Okay? So these numbers are numbers that we are naturally inclined to. So we have natural numbers as those numbers that we normally use in counting, especially in our everyday lives. So natural numbers start from 1, 2, 3, 4 to infinity. It continues and continues. Now, after natural numbers, there is another one we call whole number, the whole numbers. So we have the whole numbers as another set of number system. Whole numbers. What are the whole numbers? Okay, after talking about natural numbers, we now go to a whole other set of numbers called whole numbers. Now, this number is not too different from natural numbers. We only call whole numbers, including natural number. Whole numbers are part of, natural numbers are part of whole numbers. Natural numbers are in whole numbers, except that there is just one singular addition. And what is that addition? The addition is 0. So when you are counting whole numbers, it starts from 0. So we have 0, 1, 2, 3, 4, 5, 6, 7 to infinity. So the only difference between the whole numbers and natural numbers is what? The 0. Okay? This 0 is the addition. Okay. Now, what is the significance of these natural numbers? Or how do we use these whole numbers? How do we use whole numbers? We've said that natural numbers, we use them when we do everyday counting. But for whole numbers, for example, you want to measure the length of maybe your book or the length of a very small object. Of course, you start measuring from 0. Okay, it starts from 0 to 1. So the length could be 0.5 cm, it could be 0.2 cm, 0.6, 0.9. We start from 0. Okay, so this becomes appreciated when we are dealing with measurements that must start from 0. Of course, so that is why we have the whole number system is all the natural numbers plus 0. Okay, having got that, what are the next other set of numbers? The other set of numbers. The other set of numbers are what we call the integers. The set of integers. So we have the integers. Okay, this set of number system encompasses both natural numbers and whole numbers plus. So in the integer number system, we have natural numbers in there, we have whole numbers in there, then there is another set of numbers. Okay, so in the integer number system, let's say we draw a line to represent the number line. We may call this a number line. Okay, so in the number line, we will have both positive and negative numbers because the integers have a negative part, which is just the difference between these integers. That is what makes the difference between integers, whole numbers, and natural numbers. So if we have a line like this, we have a line. I don't mind my drawing. So we have in the middle, we normally label 0. And to the right, we have 1, 2, 3, 4. Then continues to the left, we have -1, -2, -3, -4. Continuing. So here we have both positive and negative numbers. And in this case, this is what we call the integer number system. The integers has both positive integers, okay? So we have positive integers, goes this way, have positive integers. Positive integers. Going to the left, we have negative integers, okay? Negative integers. Then at the center, we have 0. We have 0 at the center. Okay, so we have positive integers, negative integers, and then 0. So we can see that the integer captures both the natural and the whole numbers. So the natural numbers are this from this one, they are positive integers. Okay, positive integers are natural numbers. Okay, now positive integers plus 0. Positive integers plus 0, we have the whole numbers. Then when we now add the negative integers, the positive integers plus 0, all now are called integers. So we have the whole numbers, natural numbers, the whole numbers, and then the negative numbers, okay? All of them make up the what? The integer number system. The integer number system. Now there is another set of numbers. There is another set of numbers where we have what we call the rational numbers. Rational numbers, okay? So we have the rational numbers. The rational numbers. Okay, in these rational numbers, we have both the integers and the non-integers. So it's a step ahead of integers. So the rational numbers is made up of the integers and the non-integers. So the integers are part of the rational numbers, but there is another set of numbers that are not integers, which are rational numbers. Those ones are the fractions. The fractions. The fractions are in rational numbers, okay? Rational numbers is made up of fractions and integers. So you can see here we don't have any number that is fraction under integer, but there is fractions under rational numbers. So what are these fractions? So under fractions, we have both two types of fractions. We have what we call the terminating decimals. Terminating decimals. Okay, decimals like when you have like 3 divided by 2, it gives you what? 0 0.5. Sorry, was it 1.5? It gives you 1.5. Okay, that is terminating, it's finished. 1 divided by 2, 0 0.5. Okay, these are terminating. Okay, terminating decimals, they terminate. Then we have the non-terminating, okay, recurring decimals. The recurring decimals. So the recurring decimals are those ones that when you do them, you find out that it continues to go. For example, um, we have, let's say 1 divided by 3 is going to give you what? 0 0.333, okay? 333 to infinity, it continues. So you find out that they are recurring. They don't terminate, they continue, okay? So we call them what? Recurring decimals. Recurring decimals. We call them recurring decimals. They are recurring, they continue, they don't stop. So here we have under fractions, we have the terminating, we have the recurring decimals. So under rational numbers, we have integers and fractions. So here we have, in this number line, there are numbers in between. Here we have numbers like 0 0.5, numbers like 1.5, like 2.5. These are fractions, but they are not integers. Minus 0 0.5, minus 1.5, they are in between integers. We have infinitely many number of fractions, innumerable fractions. So again, so we have the rational numbers are numbers we which are integers, and then numbers which are fractions. Okay, so the rational numbers, the general formula for rational numbers are any number that you can write as, okay, as q all over, or let's say p over q, or q over p, let's say, provided that p is not equal to 0. Okay, so every rational number you can write it as this, provided that the denominator does not go to 0. It's never 0, because if it goes to 0, it becomes indeterminate, or it becomes undefined. So you can write every number that's a rational number as this. For example, you can write 2 as equal to 4 over 2 is what? Equal to 2. Okay, so 2 is an integer, but we can write it as this, where our Q is 4, our P is 2. So this is a general definition for rational numbers, all numbers that you can write like Q divided by P, where the denominator, the P, is never equal to 0. So the last kind of numbers that we are going to talk about are the irrational numbers. So we talked about rational, so the next one is irrational numbers. Irrational numbers. Okay, irrational numbers. So here these numbers are called irrational. They are not rational. Examples of irrational numbers are what? Non-recurring decimals. Now these irrational numbers are they are not recurring, they are not terminating. They have decimals that continue indefinitely. For example, something like pi is an irrational number. The value for pi is an irrational number. Something like exponent is an irrational number. Something like root 2 is an irrational number. Minus root 3 is an irrational number. 1 over root 5 is an irrational number. All these numbers are what? Irrational. If you punch it in a calculator, you see that the number never repeats itself and it continues till infinity. And so these are non-terminating, non-recurring, and they continue till infinity. So these are irrational numbers. So we've been able to complete all the number systems, the real number systems. Okay, so we have been able to do justice to the real number system. So in the real number system, we have the irrational numbers, which are pi, e, root 2, and all that. Then we have the rational numbers, which are integers and fractions. Now the integers, we have seen the integers. Then the fractions, we have seen the fractions, the numbers that has the decimal, where we have the terminating decimals, the recurring decimals. Then we have the integers. Under the integers, we have the positive integers, the negative integers, and the zeros. And then within the positive integers, we have the natural numbers. Then the whole numbers plus the positive integers plus 0 gives us the whole numbers. And so this is a summary of the whole real number system. So you do yourself good to have listened to this very interesting lecture on natural the real number system. So thank you for listening, and see you again in my next lesson, which will be, we'll pick all the number systems one after the other and deal with them, starting with the integers. Thank you, and see you in our next lesson.